Hello and welcome everyone to our webinar on how you can use a robot to lay out your jobs 10 times faster. I have to say we are quite overwhelmed by the amount of people that have signed up for this event today, so thank you very much for that. We thought it would be a mainly European event, but we have actually had people signing up from Australia, from the Far East, and a lot of people from the US. So good morning and good evening and good afternoon to every one of you. Let's start here by, after all, it is precision we are talking about. So it's 2 o'clock. We should be just introducing ourselves today. Your presenters, I'm Mads Genefke. I am involved in the sales department, and with me today I have is it our most handsome looking colleague, Palle?
Thanks a lot, Mads. Yes, my name is Palle Fløtkjær, and I have my daily work in the R&D department here in Tiny Mobile Robots. But also I'm very fortunate to be able to go to a lot of customer sites and actually see our robots being used in real world. So looking forward to speak more about the robot later on.
That sounds good. Good to have you, Palle. Just to run through the agenda quite quickly, we will say a couple of words on Tiny Mobile Robots, our company. We will talk about the challenges in layout and marking jobs today. We will get more into details with the TinySurveyor robot, and then we will have some cases from our users and what they have to say and their experiences. And in the end, we have a Q&A session. And we would very much welcome you to ask questions. You can't really ask them because you're muted, but you ask them by writing on your right side of the screen here. And we will then, in the end of the session here, address hopefully as many as we can. By the looks of the attendees, we will have probably quite a lot of questions to cover. You will also receive a recording after the webinar, so you can go through that in more detail if you wish. Tiny Mobile Robots, this is our company. This is where we're based in Malling, just outside Aarhus, which is the second largest city of Denmark. It's a really nice city, so if you visit someday, please make sure to stop by and say hello to us. It's only a 10-minute drive. So we are founded in 2015 and have full in-house production facilities here. We manufacture robots, we have R&D, we have sales and marketing department. And then also this is from where we ship all our robots to all over the world to customers and distributors in Australia, Far East, Asia, North America, and Europe. We manufacture robots that automate layout jobs. So if you see an example here, this is from an extension project of a harbor in the northern part of Denmark. They were setting out thousands of points to indicate drill holes for vertical drainage. And Martin, the operator here, said that he was doing around some 40 points an hour using the stick and the receiver and the traditional method. And the robot could actually do 400 points in 1 hour. So of course he was saved a lot of hassle and tedious work, the saw back and arms, I guess, also by having the robot to do that job. Now we also set our mark in the sports industry, where we do layouts of football fields, American football, Australian football, rugby, tennis, Quidditch even. So that's also a big part of our business. As we saw before from the example and the harbor in northern part of Denmark, one of the big challenges really is that setting out points or marking out points with traditional methods, that it can be a very tedious and time-consuming job. And some of our friends in Australia, Position Partners, they made a very good video that demonstrate the difference quite well. And yes, I think I will see if I can run that video here. It should be running now. So here you can see that the operator here gets I think it's a 10-meter lead, a head start here, and the robot is getting ready to mark out. And you can see the robot is marking out quite a lot of points already here, and the operator is on his second point. And it's already caught him up very quickly here. So what happens, of course, is that after this this operator has been marking out the points, they would need to be connected, these dots, with strings or other or paint to indicate the markings. And you can see the robot is really efficient in that way, that it just keeps working. So yes, what do you say, Pelle? Is there a lot of do you normally see that many people on these projects? I guess it's just the robot that works alone, right?
Yeah, well, of course there's a lot of people here walking behind the robot and around the robot. This is normally what we see when we are demonstrating the robot, because it attracts a lot of interest. But of course, normally you would only be one person needing to operate the robot.
Yeah, and I think this is also a quite good example in this roundabout, where you can see, which is a more complex layout job actually, where the robot simply does what it is told, and it does exactly what it's told. So laying out these curves in the roundabouts is really efficient, fast, and very working here. So I think it is, yes, it's coming up to the end here, and as you can see, it's really, that's good. Okay. Our customers are typically found within the land surveyor business. It's also a lot of construction companies, civil engineering companies, road construction, and the larger infrastructure contractors as well. That could also be having, they could be having projects in airports and harbors services, or they could be, we also have customers within airports itself. If we can just allow to take a quick poll here, it would be really useful for us to understand the audience and the background that you come with here. So if you don't mind just ticking some of the boxes for us. I think we probably have a lot of respondents already on that. So perhaps we could close it. Yeah. But the common denominator for all the different user profiles we have is that the robot is used in different project types. So it's typically within the large scale stakeouts where you see extreme efficiency from the robot. That could be also, as we have seen before, for example, in the road pre-marking jobs. As-built services or surveys is what it's actually invented for, and very, very useful for those projects. We also see it used in topography related projects, surveying in general, and of course the set out of points and marks within surveying. The key outcomes then for all of these projects is really how high quality a layout you actually get. It's based on known existing GNSS technology, so you can get 1 to 2 centimeter of accuracy, and when you use it with a total station, you even get sub-centimeter, millimeter precision on your layouts. As we've seen, the productivity is phenomenal. It's very, very fast. You can lay out some up to 600 points per hour, which is very, very much compared to a traditional or a manual method, which is more, let's say 40, 50 points, something like that. And that actually gives us cost savings on projects between 60 and up to 90% is what we have, is the feedback we have heard from our customers. One important point, of course, is safety. It can never be underestimated how important that is, and we see it's ideal for working in hazardous areas. That could be heavy traffic, it could be construction sites, etc. It really ensures a more safe work environment for our operators. And speaking of safety, we have unfortunately seen a few accidents involving the robots. The one here on the left was crashed by a drunken driver in the US. It was very, very close, but thank God nothing happened to the operator. He was away, not facing to the traffic, so he was operating the robot at a safe distance. The same happened actually in Sweden, but that was a milling machine that crashed this robot. It was a close call, but thankfully nothing happened at all to the operator here either. So that is actually a very important parameter to consider. But again, it is again and again productivity and efficiency that comes back to when we talk about the robot. And in the larger the project, the greater the gains. And we have also in this video from Position Partners in Australia, they took it to an airport that was new runway being constructed. They were planning 50 kilometers of pre-marking, quite complex jobs, letters, numbers, runways, all sorts of things, around 50 kilometers. And just for the pre-marking budget alone it was budgeted 5 weeks. And the robot actually managed to reduce that to only 1 week. So I'll see if I can run this video now.
Today we're 4 months out now from opening the runway, and this line marking is finishing off, this $1.1 billion infrastructure. I've been told about the robot, and I think to come out and actually see it for the first time today, what would have taken 5 weeks, this little robot's done in 1 week.
One of the Position Partners reps suggested we've got this piece of kit. Would you like to have a look at it? We trialled it. We calculated it was around about 52 kilometres of lines all up when you add in like the main runs and then all the little offshoots. It just made sense to get it on the project. When the line markers turned up, they just they couldn't believe it.
Traditionally, a surveyor is working in an unsafe environment, so safety is key, and that's what the TinySurveyor is doing, is removing some risk for the surveyor. Also the productivity, its speed and accuracy. You can use a GPS to drive the robot from any manufacturer.
You look at it from an overall health and safety aspect. That's what technology can do. It's actually saying, how do we make jobs, how do we make infrastructure a safer, more efficient way?
Coming to the end of the project, we just thought, look, we need to get this on board, and management was really keen to use something innovative. It's worked out really well for us.
Yes, and that leads us now to look a bit more into what it is that it actually enables us to gain so much productivity. And we will be looking now more on the TinySurveyor robot, and I will pass the mic on to you, Palle.
Yes, thank you. Yes, I will try to spend the next 15-20 minutes telling you a bit more about what the robot is and go a bit more into the depth. I will start out by looking into giving an overview of the hardware. Then we will move a little bit into the specifications of the system. And in the end, we will have a look on how you operate and actually send commands to the robot using the app interface that we developed. But first, let's start out with having this overview here of the TinySurveyor. So what you see here is some of the key components highlighted, and I would like to take out some of the key components or some of the key considerations we had while designing this robot. And one of them being that we like to have a platform which was very light and also very agile in the movements. And as you see, we have actually here a platform that is only weighing 18 kilograms. So this means that you can take the robot, put it in your car, and then go to the job site and deploy the robot. Also for the agility of the robot, the way it can maneuver, you see that we chose to have a 3-wheel platform. So we have the front wheel, which is a small caster wheel, which can actually run around freely all 360 degrees. And this allows the robot to be able to turn around on the spot. In the back of the robot, you see that we have 2 bigger wheels. So these are the motor wheels of the robot. And actually the motor is inside the hub of the motor or of the wheel. So we have a motor dedicated for each of the wheels. And these are very, very powerful, strong motors. And you can actually quite easily drive on flat asphalt or even more rough surfaces. And then also a key thing when we designed this was to design it for the industry, because I know you're working a full day and you would like also your equipment to be working for a full day. So we managed to do this by putting on quite a big battery actually, which can make the robot drive for 8 hours continued use. And if you sit out there and think, well, sometimes I actually spend more hours than 8 hours, you are able to have a spare battery and then replace the battery in the field, and then recharge the drained battery and then go on working. But of course, all the hardware we see here is one thing, but also very important is the software inside the robot. And this is actually what you could say a robot like this TinySurveyor here, if you should boil down the performance of it, you could say that we need to be good at combining the senses of the robot, but also we need to be good at designing or programming how the robot should behave. So here in Tiny Mobile Robots, we have a team of robotics engineers who on daily basis and throughout the past years, where we have had robots at different customers, several customers, and we learned a lot. So they have taken all that experience and then developed a lot on the driving behavior and the behavior in general of the robot to get to the point where we are today. Then for the sensor side, we have on the robot several sensors, and I would say the most important one is the GNSS receiver you see on top. Alternatively, you can also use a total station, but this sensor is especially important because this is actually what makes us able to drive with 1 to 2 centimeters of precision, and wherever we drive in the world, we're able to say exactly within this accuracy where we are. Combining other sensors also optimize this position estimate. So this be the motor sensor, where we can actually sense the whereabouts of the wheels. So each wheel we can see, okay, where is the wheel right now? And adding on top of that, also we have inside the robot, we have an IMU. So the IMU, you could say, is kind of the balance nerve or the balance sense of the robot, meaning that it can feel if the robot is tilted and if it's moving or not. So this we also utilize for determining if the robot is driving on a slope, and thereby the robot can also tilt compensate, so compensate for any slopes it's driving on. But combining all these sensors, we get this very accurate position of the robot, and is able to drive to a point very accurately, 1 to 2 centimeters, and also driving along a line very accurately, 1 to 2 centimeters. Then talking a little bit more about you could call it the hand of the surveyor, TinySurveyor, because this is actually what can perform some tasks out in the real world. As Mads talked about, initially the robot was designed or developed for doing height measurements, so doing as-built surveys of asphalt. But also, since we are based on customer needs, we also quickly learned that our customers could utilize a spray tool on the robot to make marks while they were out in the field. So therefore, we looked at what we could make, and we made this spray tool. We allow it to use spray cans because we found that a lot of our customers is already using spray cans, and I guess maybe you're also sitting out there and actually you have quite easy access to spray cans which you have on stock or similar. So you can use whatever height of spray can you like. You can adjust the spray tool accordingly. Also, you're able to adjust the height of the spray tool, meaning that if you like to have a wider line, you can do so. As you see, the minimum diameter and line width is approximately 2 centimeters. And with one big spray can, you're able to do approximately 600 meters of dash line, of course, depending on how you set your dash design. Or you could do, again, approximately 500 points. Then, as an extension to this spray tool, you could say we extended the hand of the robot, and we did this because also it's of course nice that you can have the spray tool in the middle of the robot, but also we learned quickly that a lot of tasks you need to go close by a road or a curb. So to be able to go close to a roadside, we add this side mount and put the spray tool on the side. And then now the robot is being able to be used for that also. For example, if you are going to mark out the position of the next layer of asphalt and you need to go close to the roadside. Then going a little bit back to what I call the most important sensor for the TinySurveyor, namely the GNSS receiver. So we know that a lot of our customers are in the surveying business and already have a lot of equipment themselves, so you invested some money already, this being GNSS receivers or total stations. So therefore we allowed the robot and enabled the robot to be able to work with all this equipment. So whatever you have a Topcon, Leica or Trimble or even a third or fourth brand, you can use this with the TinySurveyor. If you don't want to use your own equipment or don't have your own equipment already, then of course you shouldn't worry. We also have this variation of the robot called the Tiny Pre-Marker, and this one has a built-in GNSS receiver, so it's more kind of a plug-and-play solution, so you can quickly go out and use it right away. Then sticking to this external equipment, but still going a bit more into the specifications of the system. So I talk about that you can either use a GNSS receiver or you can use a total station. This of course depends on what application you are going to do. I would say that for most of the outdoor applications you can imagine a GNSS receiver would be more than enough, because this gives you 1 to 2 centimeters of precision. Then if you're moving indoor or if you need a higher precision, then you could also add a total station to control the robot instead. And we allowed several interfaces to be able to communicate with external equipment. So for example, you can communicate via Bluetooth, or you can also, which is preferable, you can also connect it, have a wired connection via the RS-232 port found in the back of the robot. And then for what is really interesting, because we are in the business of lines and points. So this is what the robot can do. It can drive along a line, or it can go mark a point. For the line side, what you need to do is have your design in a DXF file, and then you can load that to our app interface, and then inform to the robot what it should start doing. While driving along a line, whether it be a straight line or a curved line or a combination of these, the robot can drive 1 meter per second. So this means it's 3.6 kilometers an hour, which is roughly a slow walking pace, I would say. And as I was touching upon a little bit before, you can also customize the way your line should look, whether it should be one continuous line or whether you like to have a dashed line, where you can define the line length and also how big the spacing should be in between the straight lines. And now going to the interesting thing, which is the efficiency of the robot. So you see here, if you are to pre-mark 1 kilometer of road lines on asphalt, then we had a use case which actually we will talk about a little bit later. We had this use case where the TinySurveyor can do 1 kilometer of road marking in 17 minutes. Comparing this to a manual marking where you're doing it in a 3-man crew with strings and lines, they would use 2 hours, meaning a total of 6 man-hours. So this is kind of giving the idea about the savings you can have. Of course, I know the way of doing marking depends a lot on the use case and how you do it. They can be very different. Then for doing points, what you need to have there is a list of points, so a list of X and Y values in a CSV file. So this is a comma separated file. So we have this, for example, 1,000 points. You will make the robot start go to each of these points doing a mark. So what it does is when it goes from A to point B, it will drive 2 meters per second. And then just before it goes to the point, it will slow down and then use the rest of the distance to find the point very accurately. And it can actually do this, finding the point and marking the point in 2 seconds. And if we are to compare that with the video we just saw, where the surveyor is going with his stick, finding a mark and then putting a mark down, he would use approximately 8 seconds on that, looking in the video. And of course, that's a kind of a fresh surveyor, you could say. So you can imagine that he would become more and more tired over the day, which the robot will not. He will continue doing this in 2 seconds. So enough about the specifications, and let's move a little bit into how you actually operate this robot and how you send commands to it. To do so, we supply a ROC tablet, a ROC Samsung tablet with the robot. So this is a Samsung tablet which is actually made for industrial use, so it's waterproofed, and also it comes with a rock case and even has a stylus pin, which means you can more easily use the touchscreen in water conditions. So on this tablet we have our own developed TinySurveyor app pre-installed, and this app is actually what you see on the main screen, or the screenshot shown on this slide. So what you can do from here, and actually what you see here is the main screen, so what you can do from here is more or less what you need to do with the robot. So you see we have a nice background map. We have the white lines, which is the job you like to do. Those are displayed on the background map. You can simply select it and press start and have the robot start marking it. And then of course it's in a robot, you like to drive it automatically, but sometimes you also need to drive it in manual mode from the car and to the place you need to work. You can do so by using the joystick you see on the right of the app. But now to get a little bit of a better understanding on how this interface and how the process of loading a job and then starting it, to get a better understanding of that, I will start playing a video here. What we see here is when the robot is all turned up, everything is ready. You see how I nicely maneuvered around using the joystick to the point I like to start. Then you see the USB button found in the right lower corner. When I press that, I can see the files I have on my USB stick. I load my file, which is a DXF in this case. I have a nice line displayed here on the app, and I choose whether I like to drive the north direction, and in this case I choose to drive in the south direction instead. And then I can press start to make it start at the point where the robot is, so you don't need to start always at the beginning of the line. And here you see how nicely it drives towards the endpoint. So maybe you already kind of got the idea that, okay, what is really important for this robot to work is data. And you have two ways of providing data to the TinySurveyor. Either you can create it yourself, or you can have a DXF or CSV file providing it to you. So we allowed the user to create data themselves. So you can go in using the app, you can select one of the predefined templates, going from simple points, which you can go out with the robot, collect, and then replay. Or you can draw lines, you can draw circles, or even more complex things like making a parking lot, or even defining an area where you can scan. So you can define a big area and have the robot drive back and forth and have it scan that area. But I would say the most effective way of using the robot is using it with a DXF file or CSV file, because then you have all the data predefined. Because often what you see today, and I guess you already know this, that if you go to a project, all that project is digitalized already. So you can take that, more or less directly input it in the app, and then have the robot drive. But enough about all the robot in details and all that. I think we should move a little bit more onto the customer side and see, okay, what is our customers actually saying about this robot, and how do they use it in the real world?
Yes, and that's a nice picture from a job site somewhere where the robot is joined on a job. Okay, so a few customer cases that hopefully should be of inspiration to you listening out there. This is a company from the US. They do Austin Bridge and Road. They do road pre-marking, and they gave us this pretty interesting feedback on their experiences with the robot. So they effectively went from a 3-person team to do 3 hours, to take 3 hours to do 1 mile of pre-marking, down to effectively 1 person and the robot on 20 minutes per mile. And you can also see a good example here how it works with the traditional method on the manual spray, connecting the dots that the surveyor typically would mark out. And of course, the robot will mark out dashed or points or whatever is used in whatever is needed in the situation, making it actually also really interesting from a saving on paint perspective. So you save what's good for the environment also is also good for the wallet in this case. So that's a very nice example from the US here. And another company, Spotland, it's a Danish company. They acquired the robot for a highway project in Sweden, and for doing pre-marking. They actually realized that it also could be used for edge markings. Here you can see with the side mount, and also for indicating or setting out drill holes for safety barriers. So suddenly, this happens quite a lot when we hear from customers that they get the robot for one thing, and then they realize, oh, we could also use it for this and that, and that's very interesting for us to hear, of course, because it just expands the potential of the robot. Another really big industry that we have been involved in is setting out of solar cell farms. Those are typically massive projects that often need to set out thousands and thousands and thousands of points for installing all these solar cells. And this is a company from Germany that got the robot a few years back, and they estimated around some 35 points an hour they were setting out at the time. Of course, today they have more than double, should I say. They are setting out 350 points per hour now, making them extremely efficient in terms of the production time. So big savings in solar parks, absolutely. And we touched upon this before, that you could integrate or use the robot with a total station. And this is typically used in indoor areas or areas where the GPS reception signals are poor. And this is a German company that are setting out exhibition halls. Very often they change the layouts of the exhibition halls, and then they have to mark out extremely precise where the booth should be placed and what should be located where. And traditionally that is done with one operator operating the total station and another operator to do with the prism and go around and to mark the points. And that has now today with the robot you can do it's only a one person job. And of course again the productivity is increased tenfold with some 250 points or setting out per hour. They also do quite a lot of festivals and outdoor events that also mark out booths and stands and these things. So really a broad spectrum of user profiles we see for this robot. Again, more complex logos, more complex setups that we are seeing users are taking the robot to. As mentioned before, the robot will do exactly what it is told from the data. And I really like this example from Austin that they painted their own logo on the pavement here, which is really some good food for thoughts and good ideas for what it can be used for. I guess it's only the imagination that is limiting its performance here, but on a more serious note here, the layout on airports is also very complex, and Helle, I believe you have been involved in some of those projects on I believe this was on Copenhagen Airport, was it?
Yes, indeed it was. Yes, I was over at the Copenhagen Airport and seeing the robot being used there and getting to know how they could use the robot. And of course, they quickly found out it was very good and very effective at drawing the long lines they have, so doing that a lot faster. But also what we found over there was to see the robot was actually quite good also at making these letters and numbers they had to do in the airport. Because normally they had to measure those from some given points, which was kind of cumbersome and also kind of hard. But with the robot, you simply just have the drawing on your app, and you can make the robot draw these letters and numbers quite easily. So this is also what we see that of course it's not only very extensive and big jobs, which is a good thing with the robot, but also more complex tasks, as these numbers and letters can be quite useful. Yeah,
you were also involved in the other project below here. I mean that is that's really interesting, I have to say. A lot of complex lines there.
We're starting to see more interest also from construction companies with several types of indoor markings. So of course this is also more in the area of more complex jobs, because as you say, we have a lot of different lines in there which the robot needs to draw out.
Perhaps you can tell a little bit about what the different colors and lines are for.
Yeah, so in this case here they use some of the colors, so they have different colors. So they use some of it for heating pipes, and other ones for water pipes and electrical pipes and so on. So in between every floor they have to put these, and this can be marked out by the robot. And it's actually also kind of the benefits, you could say, with the spray tool. So you can just put in quite fast, you can put in your, let's say, white spray can, and you can drive around with the robot. When you're done doing all the white lines, you can insert your blue paint instead and do all the blue lines. So this is quite nice and quite quick to shift between different colors.
I think it looks very impressive with all the different lines there, and I assume also this is really a high precision job for these builders, right?
Yes. So also this would be one of the applications where you would use a total station.
Yeah, and then you get down to the sub-centimeter, millimeter precision.
Yeah, exactly, and that's also what they need in these cases, a very, very accurate marking.
Okay, there might be some questions on that, and that leads me to the next step in our webinar here, our Q&A session. We have had quite a few questions coming in, Palle, so
that's good.
So are you ready for those? Perhaps we should just mention this. We made it on the front cover here on the POB magazine, which is effectively one of the leading surveying magazines around. Surveyor of the Year. That's really that was really great to have that recognition. But let's see if we can. Okay, there's one here from Mike. Can you install the TinySurveyor app on any Android tablet? I guess that's yeah. was from,
yeah, relates to the tablet. So what we do as a tool, we are sorry.
I don't know if you covered that, but I just got that question.
Yes. So basically, yeah, I touched upon it, saying that okay, we have the Rock tablet from Samsung, which we provide with the robot, and also we like to pre-install this app that we develop on this tablet. So it's not easy or cannot be done from our side to put on the app on any tablets. We do this because it's easier to do support and do service of the app, because it's
actually, yeah, Pelle, there is a follow-up here. Perhaps what background imaging is on the tablet? Is it Google? Question is.
Yeah, the default background map is a Microsoft Bing map. But actually recently we allowed for other WMTS maps. So this means a world map, web map services. So if you have a web map service you like to use, so you have one yourself, you can also make the app use this one here. And I know some might like to do this because the background map can be more or less precise. The background map is of course very nice because you can quickly see if your drawing is put in the right area or if it's put in another country. But if you like to have even more precise background map, then you are also able to use these WMS or WMTS services.
Yeah, and that's actually a really good feature for that purpose. Yeah. Okay, there is one question here from Rodrigo in Chile. It's quite a long question, but it relates to the terrain. What type of terrain can the robot drive on? They have different the irregular terrain with in elevation, stones, desert type. I think that's also we saw the solar parks on the field there. Perhaps it's a good thing to cover that, Pelle.
Yes, I would say it's a very common question also that we get, which capabilities the robot has in terms of the surface. And of course it can easily, like we see on the picture there from the magazine, it can easily drive on asphalt surfaces. But also some of the pictures show that we can drive, or the robot can drive on more grass fields, or even in a sandy environment. Of course, there are some limitations to where we can drive with the robot. And as kind of a rule of thumb, we normally say if you can bike on it with your bicycle, then you're also able to drive with the robot on it.
Yeah.
So that's kind of the rule you could imagine if you have an area where you think, could this be used with the robot?
But okay, so what would happen? Let's say if one of the wheels puncture on a stone or something. How do you handle that?
Yeah, well, of course you would. The robot would be able to go on actually, but it's of course not as good as before. But you would just simply it's air tires, so you are similar to what you know to your bicycle. You can actually repair them yourself. So this would be what you need to do. So if you have a flat tire, you would just simply fix it like you normally do.
Okay, so another question, can you elaborate on the radio communication link between the tablet and the tiny robot? What kind of link is it?
Yeah.
And is there a maximum distance between operator and the robot?
Yes, also a very good question actually, which I didn't touch upon too much in my talk. So of course we have the tablet, and you need to communicate something to the robot. And we do this we do it in two ways. We do it either via Bluetooth or via the internet. So we have a SIM card in both the robot and the tablet. And in general, when we're sending a command, we're sending it both via the Bluetooth and the internet communication way. So this means that we have a redundancy in the way of communicating, and whatever message is coming first is being used inside the robot. Then for safety issues, we only use the Bluetooth communication way to be able to drive around with the joystick. So driving around manually needs to be done with Bluetooth communication. And this, of course, gives us a limit. So this is actually the limiting feature regarding manual drive. So this limits us to approximately 100 meters. It can vary a little bit because it's a line of sight. So this limits us to 100 meters being able to drive it manually. So every other features can also be sent via the internet. So starting a job, stopping a job, so on, changing settings in the robot. So in that case, there's actually no real limit to how far you can be away from the robot.
Okay, good. So another question here on calibration. Do you need to calibrate the robot?
Actually, what we do is from production side, when the robot is done being produced, we also do a calibration of the robot. So calibrating, because of course when we're producing it, there might be some small tolerances. So we calibrate the antenna placing, and also the position of the spray tool and various other stuff. So we do that from here before we ship out the robots. So when you would receive the robot, you would have a robot ready to be used. Then of course, if you are changing anything, for example, putting on a side mount, you could see that something mechanically is being changed, and you need to do, I wouldn't say a new calibration, but you might need to do a small recalibration. And you can do that by changing parameters in the app interface. So that's possible to do from the customer, or for the customer himself.
Okay, I have another question here from Raimund Daubauer. Is it possible to go uphill or downhill with the robot? So we're talking slopes here.
Yeah, and a little bit as I touched upon that, we have the IMU inside the robot, and this is actually measuring the tilt or the slope which the robot is driving on. So this means that the robot can compensate for any tilt. So if it's driving on a slopey surface, it will compensate for this. But we put in a safety limit also, so the robot cannot drive on steeper slopes than 15 degrees, simply so because we don't like the robot to roll over.
So that's a software setting then?
Yes, it's a software setting.
So okay, so let's say it's around the 15-degree slope. Does that have any impact on the accuracy that it's marking, or?
No, again, because as I talked about, that we have this IMU which can actually calculate the difference, so we can compensate for any slope, and also do accurate marking on a slope.
Okay, we get a lot of questions on the spray here, Palle.
Yeah.
Is it possible to understand when the spray when it's empty? I guess it means here that. So then, is there some kind of signal that now there's no more spray? You have to change the spray can, or no, right?
Yeah, it's a no for that, and it's often also a question we get from customers before they get the robot, and then the feedback I get after they've been using it for a while, they find out, okay, well anyway I need to have an operator looking at the robot, and you get kind of an idea about, okay, I can use it for 600 meters, then I need to change the spray can. So you kind of get a good intuition about when you need to change the spray can. So in practical use, it actually don't prove to be that big a problem.
Okay, we also get a few questions on the indoor features or functionality here, Palle. It says, can you elaborate a bit on how it's used indoor? I think more or less touched that, but perhaps we could talk a little bit about the total stations. Are there any special requirements to the total stations needed? What does it say to work indoor?
Yeah, because of course we need, instead of having the GNSS receiver to position the robot, we then integrate instead a total station. So that is being used instead because we don't have any satellite signal indoor, of course. So we can integrate with a total station of any brand. But of course, we do have some requirements from the robot side, which is that the total station needs to output 10 times a second. It needs to output position input. And what we have learned from using a lot of different total stations is that often it needs to be some of the high-end total stations which is actually capable of doing this. But then after that you're able to use it together with the robot for indoor use, for example.
Okay, here one says, how can I get a robot? And perhaps I can cover that one. I think that's pretty easy. Either you just reach out to us here at Tiny Mobile Robots, or you're also welcome to look at the website where you can find the list of our distributors and reach out to them directly. That's also possible. Okay, here's a question. Can you use AT&T or Verizon SIM cards for communication?
It's a very specific question also regarding the US SIM cards. Yes, and actually it's a good point. I would say I would turn around a little bit and say actually what we do to make this a much more easier thing. And we have some SIM cards which can be used more or less in every country, and those are inputted in the robot and the tablet and can be used together with the system. So when you buy the robot, you don't need to think about SIM cards and anything. You can more or less use it out of the box.
Yeah. So what are the requirements for GNSS receivers that needs to work with the robot? So that's, I guess they mean if you have one receiver of your own already, the typical Trimble, Leica, Topcon receivers, right?
Yeah. So of course we have some requirements. What I learned is that more or less every GNSS receiver can actually obtain this or do this. But the requirements from the robot side is that the GNSS receiver can output an NMEA string, NMEA TTA string, and can do so 10 times a second, so with 10 hertz. But often I think you need to have a very, very old receiver before it can actually do this. There are some brands where you need to have an extra license to be able to have this feature, but most of the GNSS receivers, I would say more or less every receiver I have seen is able to do this.
Okay, we have quite a few questions on the DXF file. How is it made? Where does it come from? How do you work with it on the robot? I think perhaps we should just very quickly recap some of that, Pelle, on the workflow.
Yeah, that's a good idea because as I told, the DXF file is very important to be able to use the robot effectively. And simply what the DXF file is it's a file which contains a CAD drawing of the project you are at. So what we see is that more or less every bigger project, whether it be motorway or solar farm project or so on and so on, harbor projects, for those projects, you would, before you start the project, you would draw it all in the computer, and you would have this CAD drawing, normally using, for example, AutoCAD. So this is already existing data, and those data can be exported to the DXF format, which is a nice format for transferring this CAD data between different platforms. So then you have the DXF file. You can get it, often you can get it from your the project owner or some of the people who have developed the project, they would have this data. So export it to a DXF format and then insert it into the app, and then you are ready to go.
And that of course also means that you, in order to make, for example, there is another question here: how do you make how does the robot make the lines that follow the course of the road? And so the workflow comes from those files.
Yes, it does. So, and maybe a good note to add is that also for, let's say, a road project, a motorway project, the drawings you have will be drawn in a special coordinate system, and then informing the robot which coordinate system has been used in the drawing. Then the robot knows exactly where in the world the drawing is, and will go do these lines as you tell them.
Right. Okay, Pelle, thank you so much for all the good answers, but thank you even more for all the good questions. We have so many questions here, and I see that the time is really running ahead of us here, so apologies to those of you who did not get your answered questions asked. We will try and follow up directly, and we would like to thank you very much for participating today. We will do a very short survey. I hope you would mind letting us know, just answering a couple of questions after this webinar. You will also receive a link. I think we can also probably include a link to the article in the POB magazine. And if I haven't forgotten anything, I would just like to wish you everyone a safe and Merry Christmas and a Happy New Year from, I guess, from both Pelle and I, but also from the entire team here at Tiny Mobile Robots. Thank you so much for joining, and we will be looking forward to hearing from you and in the new year. Thank you.